In this video, we're going to introduce the concept of matrices. But before we do, let's go back to beginning algebra, when you learned how to solve a system of linear equations by what we were called the elimination method. We had two lines, here and here, and we were asked to find out where they intersected by finding the point that they had in common, if they had one, and we solved it by what's called the elimination method. So you can say, well, what could I do to maybe eliminate the x's? We could multiply this equation by -4 and rewrite this as -4x plus 8y equals +36, and then rewrite the second equation. And at this point, we're going to add these two equations, and what happens is that the x's add to 0, so that's why it's called the elimination method. So we would go ahead and finish this up. This would be 11y equals to 22, divide by 11, and we would solve for the y variable, and we would get 2. Then we would have to go back to the original equations, one or the other, doesn't matter, and substitute in our value for y. So I'm going to use that top equation. Say x minus 2 times 2 is equal to -9. And solve for x. So if I subtract 4, well, hold on. That's a -4, so if I add 4, I get -5. So the point or the solution to these equations would be -5, 2. In other words, if we were to graph these lines, they would intersect at this point. Now, we can expand this concept by using matrices to solve a larger system of linear equations. But before we get to solving, let's just go ahead and define what a matrix is. A matrix is a rectangular array of numbers arranged in rows and columns placed inside brackets. The numbers inside the brackets of a matrix are called elements. And so this is an example. So we want to use these brackets, and we want to make sure we have clearly defined rows and clearly defined columns, being very neat and organized. Now we're going to look at what's called an augmented matrix. This is a matrix that is used to represent a system of linear equations. It has a vertical bar separating the columns of the matrix into two groups, one for the coefficients of the variables in the linear system and the other for the answers. As in, the vertical bar kind of takes the place of all the equal signs. We do want to note if a variable is missing, we assign it the coefficient of 0. So the first thing we're going to practice is just how to rewrite a system of linear equations into an augmented matrix system. So we're going to use a bracket. We have brackets. We need our vertical column. And these columns over on the left are going to represent the x, y, and z's. And over here are the numbers on the right-hand side of the equal sign. So again, being very careful, being in clear rows and columns. So we're just going to take the coefficients of this first equation. So I have a 3, a 1, a -1, then we have a 9. Here we have a -1, a -1, a 3, and a 3. This is +1, +2, -1, and 0. And that's it. Just to rewrite the system of equations into an augmented matrix system. Let's practice another one. You need to have a bracket, bracket, vertical bar. So looking at this equation, we have a 3x, 0y, -5z, -12. This one, we have 0 x's, 4y, -1z, +5. And the last one, 2x, -3y, 0z, and -4. Really quite easy. I would like for you to pause the video and do this last example. Then come back and let's do it together. Let's see how you did. Bracket, bracket, column. 2, -5, 0, -2. 4, -3, 1, 7. -5, 1, -4, +1. So on the test, when I ask you to rewrite the following system of equation in an augmented matrix system, this is all I want you to do. Very easy. Now, once we have it in an augmented matrix, we need to start manipulating the matrix around to get to the answer. But we're going to kind of start with the answer first before we start manipulating around. I want you to practice the easy stuff. So one method to solve the system of linear equations using a matrix is to get the matrix in what's called echelon form, which means to have only ones on the diagonal and zeros below. Now keep in mind, I'm just looking at a system of what's called a 3 by 3. 3 equations, 3 variables, x, y, z. But this is used in real life solving multiple equations with multiple variables. At that point, you usually need a computer, but this is just the beginning so you can understand how the basis of all of those computer programs would work. So once we get the matrix into this format, then we can solve for our variables of x, y, and z using what's called back substitution. So we start at the bottom. But first of all, let's remember these stand for x, y, and z. So this equation really is 0x plus 0y plus 1z is equal to 2. In other words, z is equal to 2. So that's 1/3 of our answers. We have z. Now we go up, again backwards, or from the bottom up to the top, and we look at the second equation. And that says 0x plus 1y plus 2z is equal to 3. But we know what z is. It's 2. So we have y plus 2 times 2 is equal to 3. Of course, that's 4. Subtract it, and we get -1. So now we have z and y. Our last thing to get is x. So we go to the very top, and that equation becomes x plus 2y, minus z is equal to 0. So I don't know what x is, but I know what y is, -1. Z is 2. So I fill all of those in, and this is going to allow me to solve for x. So I have x minus 2 is equal to 0. That's x minus 4 is equal to 0, so x is equal to 4. So we have what's called the ordered triplet, which is x, y, and z. And that is what's called back substitution. Again, I would like for you to stop the video and do this example using back substitution, solving for x, y, and z. Well, hopefully you're back. And again, we're going to start from the bottom. We're going to look at this. And this just says 1z is equal to 5. Remember, this was 0x plus 0y plus z equals to 5. Our next equation is this one. Come down here. And that says 0x plus 1y plus 3z is equal to 2. I substitute in what z is. So y plus 3 times 5. So that's plus 15. Subtracting 15, I get -13. And then my last one is I get x. So I have x plus 3y plus 4z is equal to -1. X, y, z. So again, filling in, we have -13 for y. We have 5 for z. So that's x minus 39 plus 20. That's x minus 19 We add 19 to both sides, and we get 18. So our ordered triplet, remember x, y, and z, would be 18, negative 13, and 5. So one of the questions on the next test will be, take this matrix and use back substitution to solve for x, y, and z. Now, we've seen how to begin by putting the system of equations into an augmented matrix, and we've seen the end by once we get into echelon form, how we solve. But what's that in between steps? These are accomplished by what's called row operations. Remember, rows are across, columns are up and down. So there are 3 row operations that you can do. You can interchange 2 rows. You can multiply a row by a non-zero number. Remember, if you just multiplied by 0, it would all be 0, so that wouldn't be good. Or we can kind of combine. We can multiply a row by a non-zero number and then add the product to another row. That's probably the hardest one, so let's just start with the easy one. So first of all, we need to look at our notation. This says row 1 changes places with row 2. What does that not involve? Oh, I'm sorry, that says row 3. So what row is not involved? The row that's not involved is row 2. So I am just going to go ahead and put in row 2 because that is not changing. But I'm going to interchange row 1 and row 3. So I'm going to put row 1 down here, and I'm going to put row 3 up here. And you're going, why would I want to do that? Well, echelon form, we want the ones on that diagonal, and so doing that, that gives me that 1. It's a starting point. And again, we're just looking at some very basic steps. All right, so now what does this notation say to do? This says to multiply row 2 by 2 and put it back in row 2. So this time, the only thing I'm using is row 2. So that means I am going to rewrite row 1 and row 3 and only use row 2. I'm going to multiply row 2 by 2. So I'm going to multiply each one of these values times 2 and put it in my new matrix. So I have 6, 36, negative 24, and 42. And again, that's all. We're just practicing. Okay, now we're going to look at the more complex one. This says to take row 2 and multiply that times 1/6. And you're going, ugh, fractions. Just hold on. Then we're going to add it to row 3. And we're going to put it in, replace row 3. So let's do some work. So let's take row 2 and multiply it by 1/6. So this is just kind of my scratch work over here. So here is row 2. So I say 6 times 1/6, 36 times 1/6, negative 24 times 1/6, and 42 times 1/6. You can see that all of those numbers are divisible by 6. So this is going to be 1, 6, negative 4, and 7. Okay, so that is this part, multiplying row 2 by 1/6. Now it says I need to add it to row 3. Okay, so here's row 3. Negative 1, 3, 3. And I've got to add those together. Okay, kind of running out of space. So let me come over here. Because my result is going to go in row 3, I repeat, I do not want to change row 1 and 2. Okay, so I'm going to rewrite row 1 and 2 just as they are. Now, my scratch work, I multiplied row 2 times 1/6, and I got these numbers. And now I'm going to add row 3. So 1 and negative 1 is 0. 6 and -1 is 5. -4 plus 3 is -1, and 7 plus 3 is 10. And again, if you just kind of do some scratch work and say, okay, what am I not changing? You'll be okay. And I know that's a little confusing. So let's just practice another one. What does this tell us to do? It tells us to take row 1, multiply by -2, add it to row 2, and put my answer back in row 2. Okay? So in the end, the only thing I'm going to change is this row right here. So to help me remember that, I'm going to recopy row 1 and row 3. Now, on my scratch paper, or on the side, something a teacher could read, I'm going to do what it says to do. I'm going to take row 1, which is 1, 2, -1, and 0, and I'm going to multiply each one of these times -2. Okay, so I'm going to each one of these by -2. So I've got -2, -4, +2, and 0. And then I'm going to take row 2, which is the one highlighted, 2, -5, 4, -2. And I'm going to add those together. And I'm going to put my answer back in row 2. Do you need another something to practice? Let's just see if I can make one up. Okay, so let's say you have that matrix. And on the test, I ask you to do this. I say 3, row 3, plus row 2, put it back in row 2. What would you do? Well, my suggestion would be, okay, what am I going to change? Only row 2. So that means row 1 and row 3 stay the same. So I would recopy those and say that's 4, 1, 2, -1, -1, 0, 4, 2. And then go to the side and now follow the directions. Multiply row 3 times 3. So each one of these times 3. So I get -3, 0, 12, and 6. Then I'm going to add it to row 2. And I'm going to put that answer in row 2. And you say, why did I pick that? Well, again, if we're going for row echelon form, which we're not right now, so don't panic, we would want to have 1s on this diagonal, but 0s everywhere else. And those are the 3 objectives that I want you to be able to do for the next test. I want you to be able to rewrite a system of equations in an augmented matrix form. Just rewrite it. I want you to be able to solve a system using back substitution if you were given something in echelon form. And the last objective is to use the given row operations and perform them and put them back in the correct matrix form.